Now that we've learned right triangle trig, we're going to learn how we can use trig to find any sides or any angles in a triangle. Now we are going to learn two types of rules or laws. One of them is the law of sines, and there's also the law of cosines. And basically they can be used to meet any criteria in a triangle that we need to solve. Now there's two conditions that work for law of sines. The first condition is that you know two angles in a side of the triangle. The second condition is that you know two sides and an angle opposite one of those sides. In these two situations that we've been given, we are able to find all of the missing pieces of a triangle, and we're going to solve a triangle as the directions will state. You may want to pause the video at this point because these are the formulas that you'll use for law of sines. Let me explain it just a little bit about what you see in this picture. Basically what this formula is showing is, as we know before, the side opposite of an angle has a relationship to that angle. So to find the law of sines, let's say in that one situation we know two sides and an angle opposite one of those sides. Let's pretend we know A and B. Little a and little b represent the sides. So the sine of angle A over little a, which we know, is equal to the sine of b, which we don't know, over little b. You're not going to use all of these each time, but it's the comparison that you're looking for. For right now, again, please record the formula, but it will probably not make a lot of sense until we actually take a look at examples. Before we begin our examples, please make sure that your calculator is in degrees. First example. In our triangle, we have what I think is the easiest situation. In this triangle, we know two of the angles and only one of the sides. And the side that we know is opposite one of the angles that we know. Now, I have three steps here because we have three missing pieces. We have a missing angle and two missing sides. And the direction says to solve the triangle. Now, step one, if you notice by the box, is probably the easiest and shortest step. The step is to figure out the missing angle, which we already know how to do. We know in a triangle, 180 degrees is what we have, so we take away the 100-degree angle, the 33-degree angle, and we come up with 47 degrees being the missing angle up here. Now we know all three angles, so now we can begin to do the sides. So we're going to use our formula. Now we always start with the angle and the side opposite that we know. We have to have a matching pair. So we know 33 degrees, and we know 12 meters is opposite of that. So that's where we begin when we write our formula. The sine of 33 over 12, that ratio is equal to the ratio of sine of 100 over x. The missing side we have here is where my mouse is pointing. What we want to do now is cross multiply. We've done that before, that's nothing new. We cross multiply. Sine of 33 times x is equal to the sine of 100 times 12. To get x by itself, we're going to do what we did before as well. The only thing that's different is there are the two signs here. Now one question I know I'm going to hear is, do the signs cancel out? Just like if you had pi on each side, it would cancel out. The answer is no, because it's not just sine, it's sine of 33 and sine of 100. So they're not going to be the same thing. We divide each side by sine of 33. We come up with that x is equal to 21 7/10 meter. This is the second step to finding our answer. Now in step 3, we need to find the third missing side. Now with the third missing side, you have a couple options. But remember our discussions about rounding. Every time we round, it makes our answer a little less accurate. So in this case, what I want to do is start with what we knew, which was the sine of 33 over 12, is going to be equal to the sine of 47 over x. Now what's nice about this is we didn't have to round for the angle, so we're in good shape. If you take a look at my steps, I'm just going to show those right off the bat so you can see them. If you look at them, It's almost identical to what we did before, and we came up with x equals 16 and 11 hundredths meter. Now we want to pause for a second and make sure our answer makes sense. What I mean is the longest side is opposite the largest angle. The next longest side should be opposite the next largest angle. And then the smallest side should be opposite the smallest angle. We may also want to notice that 33 degrees and 47 degrees are a lot closer numerically than 47 and 100, so it would make sense that these two sides are about the same. You want to make sure you're very reasonable and your answer makes sense, just in case you make a calculator error. I would strongly suggest that you take a look at this example and maybe try to solve it again on your own, just to make sure you've got the steps down pat. Now, example 2 I'm probably going to spend some time in class talking about because it tends to be what we have the hardest time with. If we look at our triangle on the top right corner, we know an angle and we know two sides, and one of the sides is opposite the angle we know. When we're trying to solve one of these, we always have to start with the same first step. We need to find the angle that's opposite this side. We always want to look at things that compare, and then we'll worry about the top angle and the base side. Like before, we want to start with what we know. The sine of 52 over 17 is equal to sine of theta, remember that's our variable that we're going to use for an angle, over 14. We're going to do the same thing and cross multiply. Now what's nice over here is we need to get to theta, so the first thing we want to do is divide by 17. What I would suggest you do is not type this in your calculator until we get to the last step. When we divide by 17, the left side still has sine of theta. We're finding a missing angle which requires an extra step. We're not just going to divide by sine, we want to say that the sine of theta is equal to this whole rate fraction here. We need to do inverse sine on both sides. Again, I'm probably going to need to talk to you a little bit about this in class, so don't get too stressed if you're not seeing what happens here. So what we're basically doing is we're dividing all the numbers out and inverse signing to get the angle of 41 degrees. So 41 degrees is the angle across from 14 feet. Now that I know two of the angles, if you notice step 2 looks a lot smaller. We just need to find the missing angle by doing 180 minus the two angles we know. That gives us an angle of 87 degrees. Now let's pause for a minute and make sense of what we have. These two sides are pretty close numerically, so the angles should be pretty close numerically, and 52 and 41 aren't very far apart. 87 degrees is a lot bigger than 52 and 41, so we know when we find our next side it should be considerably larger than 14 and 17. So we want to go back to what we know, and what we know is that the sine of 52 over 17 is going to be equal to the sine of 87, which is the new angle we've learned, over x. The good news is once you find one of the missing angles, you only have to do that once. And it is a little complicated, but you should be good after that. We're going to go back through and solve, just like we did before. Sine of 52 times x is equal to the sine of 87 times 17. Just like before, to get to x, we want to divide by the sine of 52. So now we've solved our triangle. To sum up before we go to your turn now, for the law of sines, you're going to always know 3 pieces of the triangle, and you're going to find the other 3 pieces. Because the law of sines is a little bit more difficult than what we've done before, I do know that I will take some time to review this in class. Now we're going to get to our turn. What are we going to do? How are we going to solve this? What's going on? Again, you want to pause here so that you can take a look at the pictures. And I also did something a little bit more helpful, which is I gave you some steps. Especially with the triangle that is first, I feel like we're going to need a little bit of a script to go through things. On the YouTube video, there will also be some links to some other helpful information.